Hi everyone! Hi everyone, it's me, and today let's explore and survive on a whole new world. A whole new world! Sorry.
I'm gonna be real with you, I've been working on this puzzle for over 2 weeks straight now, and I'm ready to go crazy! Yeah, so we're doing a video on the game Iron Lung, which is an indie horror that locks you in a submarine and throws you blind into the depths of an alien ocean of blood. It's dripping with atmosphere and intrigue and spooky mechanics, and we're not gonna talk about any of them today.
Wait, did you just mention blood? Okay.
Because this video is about the entire premise of the game. You see, the lore of the game says that decades ago, every known star, apparently everywhere, just vanished, along with all habitable planets. They, do not explain how this happened. It was...
Wait, I know. Maybe, Avengers, the Thanos snap. Maybe Thanos snap. I am inevitable. Sorry.
The Thargoids, maybe? I don't know. It happened, okay? Sometime after this big old ocean of blood was discovered on some planet, and you have to explore it for clues. And that is your portion of the game. But we're not talking about that part. We're talking about this part. The part where every sun and habitable planet goes kaput. In fact, you might call this the long-awaited sequel to my video from last year about
Super Mario.
What would happen to our world if you destroyed the sun today. However, we're going to be talking about how to survive in a universe with 0 suns. So you've Thanos snapped every sun and habitable planet from existence. Are humans toast? Well, yeah, probably, yes, definitely, yes, in our current day and age. But a far-flung, hyper-advanced, spacefaring, and space-colonizing humanity, they may just have a chance.
But having said that, at the current pace of technology, maybe not in my lifetime. Not even my children's lifetime. Not even my my grandchildren's lifetime. 200-300 years later? Maybe.
So human beings need some basics in order to survive, let alone thrive, and it's easy to forget what those basics are, given that even the worst off of us generally have access to all of them. For a human being to survive, they need bare minimum. Oxygen for breathing, heat for not freezing to death, water for not dying of dehydration, light, including some ultraviolet radiation, something resembling gravity so our bones don't grow weird, and of course, food. These are all the bare necessities a human being needs to survive, regardless of where they are. And
the more you know, I guess. The more you know. 6 things.
Usually, the sun provides a good chunk of these for us. Heat in the form of sunlight, light in the form of sunlight, oxygen and food indirectly by providing energy for plants via photosynthesis, and water, too, by keeping it warm enough that it doesn't turn to ice. Humans...
Yes, the ice age, unfortunately.
Trying to survive in a universe without suns would be extremely well off looking to live on a planet as opposed to space stations, and it's actually fundamental to some of the best strategies for surviving the apocalypse of all solar energy in the universe. This is actually probably how they found the ocean of blood in Iron Lung to begin with, looking for a place to settle, and boom! Blood ocean. Some of this will become clear when we talk about electricity, but there are some benefits that should be immediately apparent, such as not having to construct massive rotating space stations in orbit in order to create gravity. This also does away with a lot of physical space problems. And for the sake of simplicity, we're going to be using our own solar system as our primary example because we know the most about it out of any other stellar system out in the world.
But having said that, you must recognize that there are countless different solar systems all across that exist. So let's take the benefit of a doubt, shall we? Thank you.
The world? It's not out in the world. We've got lots of solar systems here on Earth. Out in the universe! Plus, future scientists can use this video as a comprehensive guide for what to do when the sun is deleted from our universe. I'm sure that this YouTube video will be very helpful. The central conceit of Iron Lung states that every star and habitable planet poofed. So presumably that does include planets like Earth, although without a sun, pretty much every planet in the solar system becomes uninhabitable. But let's say for the sake of argument that we gotta do this without Earth, and we've got some number of people already living in spaceships and space stations out there. If we're using our solar system as an example, that means that we gotta find a new place to hunker down. What we need is a place with gravity decently similar to our own, which may rule out Mars, but it's really the next bit that we need that destroys Mars's chance of being our post-solar home away from home, and that's the need for massive amounts of geothermal activity, specifically a molten core. The Earth has a molten core of nickel and iron, and it's basically just leftover energy from when the Earth first formed billions of years ago, all of it stored as heat. This molten core has a ton of benefits, one of which is the creation of electromagnetic energy that shields us from cosmic radiation. The other is, well, it's heat, and we'll get to that in a bit. The point is, we need both of these features, and Mars just does not have it. Its core cooled down frickin' years ago. There's nothing going on down there. There are, however, 4 other places in our solar system that do have a molten core and volcanic activity. Io, the moon of Jupiter, Triton, the moon of Neptune, Enceladus,
Enceladus. Hopefully I'm pronouncing correctly.
Enceladus? Could be Enceladus. No. You took Latin, Austin. It's probably more like Enceladus. Anyway, this moon of Saturn, whatever it's called, and Venus, the second innermost planet of the solar system. And 3 of these, the moons, are kind of terrible candidates because their gravity is abysmal. Venus, meanwhile, has a gravitational pull of 8.87 meters per second squared. That's just 10% lower than Earth's gravity. That's pretty good. But it's here where I start.
Oh, wait a minute. I thought Earth gravity was 9.81 meter per second square. Why is it 9.6 meter per second square?
Started to run into problems because while Venus is a fantastic planet for several reasons, not the least
Did you make a mistake, Austin? Did you make a mistake?
Of which being that it would probably still be pretty darn piping hot by the time we got there, it has one major flaw that cannot be overlooked. A total and complete lack of water. And I don't mean just like liquid water, I mean water in all its forms, period. Because Venus at this moment is a blisteringly hot 820-ish degrees Fahrenheit, or just over 437 Celsius, which under most conditions is very bad for liquid water. But no, it's worse than that, because in analyzing the data that the probes that were sent into Venus's atmosphere gathered, they discovered that the humidity in the atmosphere of Venus is 100 times too low for even the most drought-resistant organisms on all of planet Earth. And this is gonna be a problem since, I mean...
A huge problem, yeah.
Water is on the list, and it is vitally more important than gravity. You can survive at least 340 days without gravity, but you can die in as little as 3 days without water. Wherever we are settling post-sun is going to need to have a metric butt-ton of water around, so Venus, unfortunately, is out. Which means we gotta look back at our other options. This brings me back to our previous candidates, the moons of Jupiter. Jupiter actually has 53 named moons and a total of about 79 altogether, each with unique characteristics, qualities, and material makeups, which is what makes this such a fantastic place to settle in a post-solar galaxy. You see, the instant the sun is deleted, the planets are going to go zipping off wherever the heck they want, and we'd likely never see anything but the planet we settled on or near ever again. So Jupiter, in spite of being a horrible planet to live on, is a great place to settle because it's going to take its moons with it when it goes flying away, including the moon Europa, which has a crust made out of water, and it may even have liquid water on it. And there's Io as well, which has the most volcanic activity out of any body in the entire solar system. This is due to the unique situation going on in Jupiter's orbit, where the strong gravitational pull of Jupiter and the lighter pull of the nearby moon stretches and squishes Io, causing it to heat up due to friction. It's kind of like if you bend a paperclip back and forth a bunch of times and the metal gets really hot. Like, actually, it's not even kind of like that. It's exactly like that. And this is where I think we should settle and just take our chances at the much, much lower 0.18 Gs of gravity and its possible health effects. And
True, understandable, like lesser gravity, but we will still be alive. Yay, I guess.
why do I want to settle humanity here? Well, that brings us to our next set of needs on our list. Heat and light, all of which are things we can, at the moment, produce without a sun with electricity. Actually, in reality, power is our biggest concern out of everything here. If we get...
Yes, power. With great power comes great responsibility. I'm sorry about Spider-Man quotes. I'm sorry.
That, everything else is just details, as long as we have the adequate materials nearby. Solar power is out of the picture without, stars and the sun. Just 5-ish hours after the rapture in Iron Lung, all of the light sent out from our sun will have left the solar system. We will continue to get light from Proxima Centauri, the closest star to us, for about 4 years and some months, but how much power can we really suck out of that light? Well, we can figure that out using some math. If we know the luminosity in watts of Proxima Centauri, that is the amount of energy it's outputting in light, we can...
Wait a minute, did you just mention, not enough sunlight, but still you actually measured it? Why?
And then figure out the watts per square meter that is reaching us in available energy by the time the light from it reaches us here in our solar system after traversing 4-ish light years using the inverse square law, which basically says the further away you are from a source of electromagnetic radiation, the weaker it gets. You can envision this kind of like a balloon where if you draw a face on the balloon and then blow it up, all of the ink stretches out and it gets thinner. This is the same principle as what happens to energy in the form of electromagnetic radiation leaving a star. And it's actually a pretty simple formula. It is this formula. You just take the output wattage of the star and you divide it by the surface area of a sphere, the radius of which being the distance between the star and wherever you are. In this case, 4-ish light years from Jupiter to Proxima Centauri. Putting all of our numbers in and
that's some big numbers.
And hitting enter, we get a result of 36.5 picowatts
Austin missed one, but it doesn't remember that.
per square meter. To put this into context, this is 38 trillion times weaker than the sun reaching us here on Earth. For the sake of comparison, the strongest FM radio stations in the United States are allowed to output over 100 kilowatts of power at their source, which, using this same law, tells us that only a mile away, the power reaching you is only about 3 milliwatts per square meter, and this is still 3.5 million times more powerful than the light that would be reaching you on some space station floating in the middle of nowhere 4 light years away from Proxima Centauri, and you can't even really pull meaningful amounts of power from radio station broadcasts either.
So, case in point, solar panels out of picture, I guess.
Solar power is out of the question. This leaves us with a few options in the world of Iron Lung, some of which are within our technological reach right now, and some that aren't and maybe never will be, like fusion power. Within our current technological grasp, we have wind power through the form of wind turbines, hydroelectric power from water flowing through turbines and dams. We have fossil fuels that we can use to boil water, turning it into steam, which will then turn turbines. Do you see where I'm going here? If you can can create movement, in particular rotational movement. You can turn that rotation into power. Humans have actually been doing this for centuries, using water wheels and windmills to grind wheat berries into flour or to bellow forges to keep them hot by pumping air in, harnessing the energy moving about in the universe to spin things to benefit humanity is some of the oldest technology in the book, and we still use it today, except instead of grinding wheat, though I'm sure there are people who still do that, we use the power of rotation to create electricity. Now we're going to sidestep explaining AC phases as to not make this video 1,000 years long and to avoid getting too complicated, but the basic principle is that electricity is created when moving magnetic fields disturb standing or inert electrons in some kind of conductor like copper wires. Moving electrons is, it's electricity. So what you do is you wrap some wire in a loop like this, shove a magnet in the middle of that loop, and then rotate that sucker. The spinning magnetic fields then disturb the electrons in that coil. Bada bing, bada boom, you've got electricity, baby! There are two major ways that we achieve rotation. One is to take something that's moving already, like rushing water or the wind, and put a blade in its way. Fluid dynamics create lift on the blade if it's curved correctly, which can then be used to spin a turbine. You slap a
a wind turbine, a water turbine. Ta-da!
Magnet on that turbine and some coils, and bam, baby, you got electricity. The other way is to use some sort of fuel to heat something, like water, to make it boil and then turn it into steam. This steam is then sent through a pipe under pressure to pass over blades in, you guessed it, a turbine. Fuels can vary from coal to, I guess, wood if you're feeling desperate, but one of the popular, well, should be popular, but isn't, is uranium-235. And you just take highly radioactive uranium rods and use the heat from them to boil water. But humanity in Iron Lung is likely going to be living on a planet that has little to no atmosphere and likely won't have any dinosaurs or algae to die on it to become oil or natural gas. And this is a dismal fact I learned while researching this script. It is believed by astronomers, or many astronomers, that most of the metals in our solar system are within the inner planets: Mercury, Venus, Earth, Mars, and the asteroid belt, which this does mean some vital materials like iron and everything else will be difficult to come by. It means that extremely rare metals like uranium, plutonium, thorium, they're going to be extremely difficult to come by, if not completely impossible to find. But never fear, we have another power at our disposal, and it's specifically why I chose Io over any other place in the solar system: geothermal energy. Geothermal energy works by taking naturally occurring pockets of steam in a planet's crust that has been heated by the hot core and upper crust and tapping into it, then just using it like you would any other steam engine. It could be argued that geothermal hotspots are actually steam engines, just naturally occurring ones. And to boot, even if an area doesn't have naturally occurring sources of steam, you can make them by pumping water beneath the surface. And this
artificially instill water into the system. Install water in the system. Introduce water into the system. Yes, that's the word.
I think in a sunless universe is the key to humanity's survival, and it uses technology that we already have. And if we're on a planet like Io that has a ton of volcanic activity, our geothermal hotspots are going to be all over the place. And this also highlights why I chose Jupiter in general. It's a wellspring of natural resources. Not only does the gravitational stretch of Io make it really easy for us to essentially turn Jupiter's strong gravity into energy, but the bodies that orbit it might as well make it a tiny little solar system of its own. Europa's got ice, which can be mined for use in pumping into Io to turn into electricity, or even more importantly, melt it so you can grow food and drink it, or use that electricity you just created from your geological power plant to zap that water silly, turning it.
Yes, and case in point, you must recognize that we are talking about an age where human beings are able to travel in space on a regular basis. So yeah, planets to planets, moons to moons, quite easy.
Into beautiful, breathable oxygen. This is a bit complicated to get into the specifics of, but by putting an electric current through water, you can force a number of chemical reactions to take place, one of which is the splitting of free water ions into hydrogen gas and pure Oxygen hydrogen has a number of uses, not the least of which being that it can be used as a rocket fuel. Electricity can also be used to power sun lamps, which are lamps capable of emitting low levels of UV radiation, which is a vital form of energy needed in humans to stimulate the production of vitamin D and to keep us from going ballistic in wintertime. The latent heat of Io can also probably just be harvested in some useful way to keep us warm. In fact, bunkers built on the surface of Io will probably struggle to keep the heat out, given how piping hot the area is. With all these things finally crossed off our list, we can finally come to food. With water, electricity, artificial sunlight, and heat, we basically have all we need to fuel massive hydroponic plants using nutrient-rich water sources. This is providing we have available seeds. If we don't have seeds, you better pray that 3D printing has gotten advanced enough as to be capable of throwing atoms together to form proteins. Otherwise, we are just, we're dead. As long as survivors of humanity were numerous enough, like 500 to 1,000 or so, to avoid major problems with inbreeding, and could survive long enough in space to establish infrastructure on the surfaces of both Europa and Io, and probably mining operations on Ganymede for raw materials, Jupiter could very easily become a thriving hub for surviving humanity. The heat in Io could provide energy for millions of years, more than enough time to construct an intricate web of subterranean bunkers, mega farms, towering, hermetically sealed skyscrapers, and YouTube 2.0, all without massive oceans of blood on alien planets. Yeah, did you forget we were talking about a video game for a second? I didn't. That game is, that's a game about, submarines. That one. That said, we are currently struggling to even get, like, a handful of people to Mars, and setting up some kind of permanent base there would almost certainly kill a whole bunch of people, so, honestly, if the sun were snapped out of existence tomorrow, we would be absolutely screwed, beyond a doubt. But it is technically possible for us to survive.
A few hundred years from the year 2022, maybe 200 years later, in the year 2222, I'll be dead. I'll be dead by then. Yeah. Maybe my children's will be there as well. My grandchildren, my grandchildren will be there as well. My great-grandchildren, maybe if they're watching this in the year 2022, it might be possible. Hopefully.
Technically. Anyway, play the submarine game. Sincerely, Austin. I just have to throw out a personal thank you to my Patreon patrons who made this possible, like Juan Santamaria, MadLad616, Miss Kendra, Alan Hagers, Adadam TP, Nicholas Bollinger, Marissa Resnick, Nick Patterson, and Loretta Mazurf. I will see you guys next time. Yeah, I don't have anything clever to say. I ran out of steam. Maybe I should get myself a geothermal plant. Okay, I'm done.
I got a joke. But anyways, I'm just glad they chose a planet filled with blood, because blood is liquid, and blood contains a lot of different elements into it, right? And also blood is a form of liquid that can dissolve and keep it. Okay, that's horrible. That's a huge eyeball. Yep. Okay, so the more you know, I guess. It's terrifying in this current day and age, but give it 200, 300, even 500 years later, things might be different. You can't say for sure, by the way. So anyways, thank you all so much for watching this video. If you do like this video, please remember to like, share, and subscribe to my channel, and comment down below if you have any about us. Don't forget to follow my channel. I hope to see you in my next live stream. But hey, that's just the next video. But hey, that's just the signs. The signs of. Thanks for watching. Thank you. And I hope to see you in my next live stream, next video. Bye. Subscribe. Oh my god, I think it's a silly mistake, man.